All right, for the first 5 questions, we're going to set up an equation based on what the sentence says and then solve it. So in the first one here, we have 3 more than a number is 50. So if I translate this into an equation, I need a variable. So I'm going to use x. And I'm saying we have 3 more than this value. And the language there is telling us to add 3. So we're increasing this number by 3. Now I see is, and that's going to represent an equal sign, and on the other side is 50. So this is, we have 3 more than some number is 50. You could have put this as 3 plus x, that would be fine too, but once you have your equation, you can solve it. I would subtract 3 from both sides, and that takes us to our answer, which is x is equal to 47. Okay, for the second question, here it says half of a number is 85. So the language in here, if I say half, you could actually think of that as a fraction, 1 over 2. When I see of, the operation that we're going to use is multiplication. We're taking 1/2 of something, and then again, I'm going to let x represent my number. Is means equals, and then we have 85. So half of a number is 85 is this equation here. So to solve this equation for x, so I'll go over this way a little bit. I suppose I'll take 2 and multiply that to both sides of my equation. So that is, I'll take 2 over 1 and multiply that to the left side, which is 1/2 of x. And that's equal to, and on the right side, I'll just put 2 times 85. What happens is, on the left side of my equation, all of that cancels to give me just x by itself. And on the other side, I have 2 times 85, and that is 170. And that's the answer for this next one. All right, let's look at 3. 3 times a number is 81. So again, there should be some language in this sentence that tells you what operation you're using, and I think this one is more direct than the previous. When I see times, that means we're going to multiply. And to say 3 times something means 3 times a number is 81. You could have just put 3x instead of 3 times x, but sometimes it's nice to put the operation in there so you can see it. This equation is pretty simple to solve. All we have to do is divide both sides of the equation by 3. In doing so, on the left, we have, I'll go over this way, 3x over 3 simplifies to just x, and then 81 divided by 3 is 27. And that would be the solution to this equation. Now, if we check out 4 and 5, all right, things are becoming a little bit more complicated, but let's see what happens. In 4, 1 more than twice a number is negative 15. So this means there's 2 operations in my equation. So I see 1 more, that makes me think addition, and then twice a number means we're going to multiply some number by 2. And we just want to be careful, the order in which we do this. To me, I read this as 1 more than twice a number. Twice a number is the first thing that's happening, so I'm going to put 2. I'll just put 2x. That is twice a number. And to say you're 1 more than twice a number means you would add 1 to it. Is, again, is my equal sign, and then I'll put negative 15 on the other side. So this is definitely 1 more than twice a number. Again, we're working with very simple equations here, but I would subtract 1 from both sides. This gives me that 2x is equal to negative 16. I would then divide both sides by 2 to give me my answer that x is equal to negative 8. And for the last question here, we have, when a number is increased by 1 and then doubled, the result is negative 8. So if I look at the operations that appear in here, again, when a number is increased by 1, that means add 1. and then doubled. So again, we're multiplying by 2. This is a lot like the previous question where you're going to multiply by 2 and add 1. But the difference is the order in which it happens is the opposite. By that I mean, I first want to increase the number by 1. So if I start with my variable, x, I would first increase it by 1, but then I want to double that entire thing. How is this different? It means I'd put some parentheses around the x plus 1 and multiply that by 2. This is we first added 1 and then multiplied by 2. The result at the very end is equal to -8, and this is the equation we'd like to solve. So to solve this equation, I would divide both sides by 2. That changes my equation into x plus 1 is equal to -4. The parentheses were unnecessary, so I could just put x plus 1 is equal to -4. My last step would be to subtract 1 from both sides, and this is actually my answer. X is equal to -5. So questions 4 and 5 are important because they illustrate this idea that when you have two different operations, like multiplication and addition, you have to be careful about the order in which they occur. For 4, multiplication was first, addition was second. For question 5, addition was first and multiplication was second. So the first 5 problems were pretty simple word problems. I think 6 is going to be a little bit more involved, so let's check this one out. Okay, the larger of two numbers is 3 more than twice the smaller number. We're also given that the sum of the numbers is 51. Well, what two numbers make these two sentences true? So this problem's a little bit harder because, well, first of all, we have two different variables. We have a larger number and a smaller number. So what I'm going to do is define my variables. I think I'll let s represent my smaller number, and L will be the larger number. I'm going to try to take the first two sentences and use these variables to create equations. Let's start with the first sentence. Okay, it says the larger of the two numbers. That's what I'm calling L. We're saying it is. So it's pretty easy to start this equation by saying L is equal to. I'm saying the larger number is, and then it says 3 more than twice the smaller number. This part of the sentence is telling me that, okay, I'm first dealing with 2 times the smaller number, and then I'm increasing that by 3. So that would be twice the smaller number, but it's 3 more than that. And that's actually an equation that represents the first sentence. Now what about the second sentence? It says the sum of the two numbers is 51. That one I'd say is pretty simple, where I have S and L, and we're saying we're summing those two things together. So you have S plus L, and we're saying that is 51. So this question's harder because, all right, well, we needed 2 variables. We ended up with 2 equations. The goal is to now solve for both S and L. And how can we do that? What I'm going to do is note that, well, L is equal to 2S plus 3. And here we have L in the second equation. I'm going to take 2S plus 3 and put it in place of this L, since they are equivalent to each other. So that is, I'm looking at my second equation, which is S plus, but I'm going to put 2S plus 3 in place of where L was. So you know L was right here. L is the same thing as 2S plus 3, so I'm just writing it right there. And the rest of my equation is 51. So what we've just done is we took these 2 equations and condensed it down into one equation. And this one equation only has one variable, and that variable is S. So that means we can solve for S. Here I have S plus 2S. I know that is 3S. Plus 3 is 51. So if I want to solve this equation, I would subtract 3 from both sides. I get that 3s is equal to 47, 48, and then I'm going to divide both sides by 3. So 48, if I divide by 3, is equal to 16. So that's the smaller number. The smaller number has to be 16. Well, what was the larger number? I have this equation that connects L and S. Why don't I just put 16 in place of S, compute this to figure out L? So I'm going to do that off to the side. So that is, well, L is equal to 2 times S, which we just figured out was 16, and then we add 3 to it. So we could do this in a calculator, but 2 times 16 is 32. If I add 3 to that, I get 35. So I have my larger number, I have my smaller number. If you want to be careful, you could check that if you add these two things together, that you do in fact get 51. Just, you could type that in a calculator if you wanted to. Yeah, it is 51, and that means we have solved this problem. All right, so all those word problems had no context to it. It was just getting comfortable with working with equations. So question 7 has a little bit of context. So the idea is there's a student in a class, and they've taken 3 quizzes so far, and they got an 80, a 60, and a 65. So, a couple of lower scores here. So they have a 4th quiz that's coming up. What grade must they get on this 4th quiz in order to have a quiz average of 70? And then after that, is it possible for the student to get an average of an 80? So to understand this, you have to know what it means to average something. Like if you averaged these 3 quizzes, that means you would add them up and divide by 3, and whatever that number is would be the average. But here we're saying we want to average 4 things, where you need to include a 4th quiz. We don't know what it is, so I'm actually going to define that to be my variable. X is the 4th quiz grade. We just don't know what it is. If I put this into an equation of an average, including the first 3 quizzes, it would be as follows. You would take 80, you would add 60 and 65, and then you'd add in this 4th quiz, whatever it is. If you're averaging those things, you're dividing that by 4. This is what it means to average your first 4 quizzes. And we're saying, if you do average those, what grade must this be in order to get a 70? You're saying, is the average 70? And this is our equation. So I simply added the first 3 quizzes and then X, divide by 4, and said it should be 70. That's what I want the average to be. All right, let's solve this equation for X. I think I'll start by adding those 3 quizzes. That's 205. So I get 205 plus X divided by 4 is 70. And I'm trying to solve for X, and this 4 is in the way. I'm going to multiply both sides of my equation by 4. So I'll put a 4 over 1 here, and then I'll put a 4 here. On the left, the 4 and the 4 over 1, like this, cancel. And then 4 times 70 is 280. So we get 205 plus X is equal to 280. The last thing to do is to solve for X by subtracting 205 from both sides. And when I do that, I get that X is equal to 75. So what we've reasoned out is, for this student, if they got this on their first 3 quizzes, if they get a 75 on the 4th quiz, it means their quiz average would be a 70%, which would be, I guess, considered like passing for a lot of classes. Okay, but what about this second statement? Is it possible for the student to get a quiz average of 80? So there's a couple of ways to approach this, but I'd say maybe the simplest way would be just to go through this process again, but put an 80 on this side of the equation instead of a 70. So I'm going to do it that way. So I'm just taking the same equation, and then I'm going to put that equal to 80. And the process of solving this is going to be pretty much identical. My first step is going to be to multiply both sides of my equation by 4. You could do that as your first step. But I also know that these 3 quizzes sum to 205. So I'm basically just going to jump down to an equation that looks like this, except I'm multiplying 4 to 80. So let's do that. My equation is 205 plus x is equal to, and 4 times 80 is 320. To solve for x, I'm going to subtract 205 from both sides. And I get that x. I don't think this is good here. 320 minus 205 is 115. I mean, that's the answer, but now here we could interpret our answer. Like, they'd have to get 115 on their 4th quiz. Well, I think, unfortunately, unless there's some bonus points on this quiz, that's impossible. I mean, the quizzes in this class only go from a 0% to a 100%. So to really answer this question, is it possible for the student to get this average of an 80? The answer would be no, because this is a quiz grade that you cannot achieve. So I'm just going to make a note that, well, that's not possible. All right, let's check out question 8. It's similar in that we're dealing with averages, but this is slightly more complicated. So let's see. We have a grading system, again, in a certain class, but this time it's not just quizzes. The system is each quiz counts once, each test counts as 2 quizzes, and the final counts as 3 quizzes. So that's meaning the tests and the final are more important than the quizzes. So quizzes are less important than tests, are less important than the final in terms of having an effect on your grade. So let's see, a student in the class receives scores of these 4 grades on their quizzes, this grade and this grade on their 2 tests. But the question is, what grade must the student get on the final exam in order to get a 70% in the entire class? All right. So the good news is that we're dealing with an average again. So I'm going to set up a fraction. But before that, I'm going to define my variable, x. That's going to be the grade on their final exam. I'll just put grade on the final. I think with that, we can set up an equation that looks a lot like what happened in question 7. So I'm going to set up this gigantic fraction and start averaging things up. Well, if I start with their quizzes, you get a 70, an 85, a 20, and a 50. So those first 4 are their quizzes. Well, now we also have to average in their tests. Okay, they got an 87, so I know you have to put an 87 into this average, but tests count twice as much as quizzes, and all that means is we just add it in twice. So this would be like the first test, I'll call it. It's the first test. I'm writing it twice because we're told that the tests count twice as much as quizzes. But we have to do the same thing for that second exam where they got a 43, so I have to add that 43 in 2 times, again, for the second test. The last thing that determines their average is the final exam, and the final counts as 3 quizzes. Now, I'm calling the final x, and it counts 3 times, but that just means you put it into your average a total of 3 times, like that. So this would be for the final. Okay, I have to set it equal to something, so I'll maybe do that next. The question we're asking is, well, what do they have to get on their final to get a 70% in the class? But the second thing is, or I guess really the last thing, is what are we dividing by? And the previous question was simple. We just divided by 4 because there were 4 things. Well, the way I have it written out, you can just count how many things there are. We have 4 quizzes, then it's 5, 6, 7, 8, 9, 10, 11 items. So this is where you'd have to be careful. You have to divide by 11. That's because we're counting tests twice and the final 3 times. Okay, the next part is to simplify this. So I'm going to do that by getting a number, by adding all of those things together and simplifying my expression. Okay, when I type that into my calculator, I got 485 plus, and I'm going to call the x's 3x, and I'm dividing by 11. This is equal to 70. So again, that was, I added up all of those numbers, I got that value, so I simplified it. So now I have to solve this equation for x. I'm going to do that by multiplying 11 to both sides. On the left, I get that. Let's see. Those 11s cancel. So I get 485 plus 3x is equal to, and then 70 times 11 is 770. I then will subtract 485 to both sides, which gives me 3x is equal to 285, and then I'd like to divide both sides by 3. And I get that x is equal to 95. Okay. In order for the student to get a 70% in the class exactly, it means they have to get a 95 on the final. So, I don't know. I mean, that's, pretty close to perfect. I mean, it's possible. At least it's a possibility. Like in this part of the question, it was impossible. So in this situation, I see the student got a low quiz and a low test score, but in theory, I mean, they could still pass this class. Anyways, we set up the equation, we got this value, and that's it for this problem.